let x be uniform on the following 19 integers. It's uniformly distributed on this discrete set. The set is -9, -8, -7, etc. 0, 1, 2, up to. So you see they're all together 18 plus 1, so 19 elements in that set. And when I say x is uniformly distributed over that set, that means the probability that it takes any one of these numbers is 1 out of 19. Probability x equals I is 1 over 19 for any integer I such that for any integer I in this set. All right. So we're interested in find probability that x squared is less than or equal to 5. So now we're interested in the probability not of x but of x squared. So even if I hadn't told you how to, even if I hadn't mentioned this, you realize that you've got to write it in terms of the probability of x. And so when this x squared less than or equal to 5, that is when the absolute value of x is less than or equal to the square root of 5, right? Or in other words, it's when x is between negative square root of 5 and plus square root of 5. So that's exactly what I'm doing here. I'm writing the probability distribution of y in terms of x. So probability x squared less than or equal to y is just the probability in terms of x that x is between negative square root of y and plus square root of 5. Okay, so square root of 5 is some number between, well, it's more than 2 and less than 3, right? So it's some 2 point something. So this is just the probability that x takes values in the set. So it's -2, -1, 0, 1, 2, right? So for the probability that x takes these values. And so this is just the probability x is -2 plus the probability x is -1 plus the probability that x is 0, etc. So I add up 1 over 19, how many times? 2, 3, 4, 5. 5, yeah. So this last step here is basically what I've written out here. I add up the probability of the different values x should take so that this holds, such that x squared is less than equal to 5. Let's just continue with this example and do one more problem. So same example. So that was the first question. The second question is find probability that x minus 2 is less than or equal to 5. So here I'm interested in the probability that some function of x, the function being absolute value of x minus 2, is less than or equal to 5. So again, the trick is basically to write it in terms of probabilities for the random variable x. So this is just probability that and then I just add 2 throughout. Probability that minus 7. And this is just the probability that x takes value between, so x takes value -3, -2, -1, all the way up to 7. So that's so 7, 9, 10, 11. This is just the probability that x this value is the second. Seven, 8, 9, 10. So in the discrete case, this is kind of easy. You can just write, you can just basically solve for x here, and write it in terms of probabilities of what values United variable x should take. In the continuous case, it's a lot more complicated. So I think with discrete, this I think this is probably good enough. So let's move on to the continuous case.